Hey guys, so a couple weeks ago, I built a garage door opener based on our favorite microcontroller, the ESP8266. Now, when I made that video, all it was a very simple device. It used the ESP, and the ESP basically just listened for command through MQTT, and when it received a command to either open or close the door, it would trigger a relay that would open or close the garage door. Now, one of the features that I said I wanted to include with this was some way for the module, for the system to know whether the door was open or closed. So that's a feature that we're going to tackle today. So what I have here is a ping ultrasonic rangefinder, an ATtiny85 DigiSpark, and a couple of resistors here. These are 1K resistors. Now, some of you guys might be asking, why am I using a DigiSpark when I'm already running the garage door on the ESP? Well, there are a couple of reasons for that. The main one being that the ping sensor runs on 5 volts and the ESP runs on 3.3 volts. Now, yes, you could make a voltage divider, and in fact, that's what I'm going to use these resistors here in this build today. But rather than having to do some voltage divider and sending a 3.3 volt signal to this, which will be far away and all of that stuff, instead of doing that, I'm just going to use a DigiSpark and offload all of the work of the ping sensor onto the DigiSpark. Yes, it's overkill. I'm not really going to be doing anything special on the DigiSpark, and I could just put it directly in the ESP code. But because it requires microsecond level timing, and I don't want to take away from the network connectivity and all that stuff from the ESP. Yes, just to put it out there, I know I could do it all on the ESP. I'm just choosing not to for this video. So I'm going to take that out of the way. And the idea here is that this device will control the ping sensor and send ultrasonic pulses over and over and over. And it will read those pulses and figure out how far away some object is from the rangefinder. And the object we'll be looking for is the garage door. So when the garage door opens, when it opens up, it's going to block this ultrasonic rangefinder, which will be pointing kind of at the floor. So when it goes up, the garage door will block the sensor. This will read some small distance, and it will output just a high or low signal on an output pin, which will be eventually connected to the ESP8266. So the ESP module will just simply have to look for a high or low signal on a pin, rather than having to constantly pull this sensor and do all the pulse in and all that calculation. So what I'm going to do here is wire up the ping sensor onto pin 2 on this device. And then on here with these little resistors, I'm going to create a voltage divider on pin 1. And that voltage divider will drop the voltage down from an output voltage of 5 volts down to, these are both 1K resistors. So it will drop it to 2.5 volts. Now, yes, technically it should be 3.3 volts to come in here, but I'm lazy. This is ItKindaWorks, and this will kind of work. And a 2.5 volt signal coming to the ESP should be enough to trip an input pin flipping to high. So that's the idea. I'm going to get it neatly soldered up here, and then we'll be able to take a look at the code that makes all of this work. All right, so there we go. We've got the ultrasonic rangefinder hooked up, and we've got our little voltage divider here to drop the 5 volt output of these pins from the pin that we'll be using, which is pin 1. And that will drop it down to 3.3 volts, which will come out this wire, go down this long cable, and eventually connect up to the ESP that controls everything. So now this is going to require 2 modifications to our code. First, we'll go over the code that is going to run on the DigiSpark here, and then we'll take a look at the modifications for the code for the ESP. And once we've gotten that taken care of, we can go test it out. All right, so here we have the code for the garage door sensor. And it's, again, just like I try to make it for you guys every time. It's pretty simple. And up at the top here, we declare the 2 pins that we're going to be using. So the ping pin and state pin. So the ping pin is the pin that will be connected to the sensor and will actually be triggering and receiving input from the sensor. And the state pin is the output. That's what we'll be putting high or low depending on whether the garage door is detected to be open or closed. The only line of code that if you want to try this out, you might have to change in this program is this line right here, this trigger distance. This trigger distance is how far away the sensor will detect to determine whether it should flip the pin high or low. So in my case, I've chosen 36, and this is in inches, so 36 inches. And I've chosen that just because if it's 3 feet or less away, i.e. there's some object in front of it, I want that to be a detect of open, and anything else that's further should be closed because the door will not be blocking it. So then we have one more variable here, inches, and that's how many inches have actually been detected by the sensor. So coming down into setup, we set our state pin, which is the output pin, as an output, and we set it to low, which I just basically flipped a coin and picked low, which is what I'm calling as open. That's what the ESP, if it sees low, it will detect that the door is open. Coming down into loop, the first thing that we do is we get a new reading from the sensor running the ping command. And the ping command, this code and these comments are all just stolen out of the ping example code in the Arduino program. I just copy and pasted it. And we basically give a little pulse to the ping pin, which right now we set as an output. And then we set it as an input. And we just wait for the ping sensor to flip that pin high and low again. And this time we're reading it. And the time that it took for us to tell it to run and the time that it actually pinged back, we do a little bit of math down here. And this gives us the number of inches that have been detected by the ping sensor. So that's all we're doing down here in ping. It's just running a little function that triggers and reads the sensor and gives us back a number of inches, which we use up here in loop as a way to set the output pin. So if the red number of inches is less than the trigger distance, i.e. the door is open, we will set the pin to low, and otherwise we will set it to high. And then I just wait 100 milliseconds between readings, and that is all that this little sensor does. So now that we have seen how this works, let's jump over to the program, the updated program that will run on the ESP module. Okay, so now that we've seen how the sensor code works, let's take a look at the garage door software. So up at the top, we have ESP helper, and we have some macros for time. And I believe you guys have seen these already in some of my other videos, including the first video for the garage door opener. And we have a whole bunch of other definitions for the status topic, the relay topic. All of these I went over in the last video as well. So if you haven't seen this, go watch the first video and then come back here. And then I also have this wait time. So wait time is basically a macro that defines how long it takes your garage door to open. So mine takes about 18 to 20 seconds. So 19 seconds is perfect for me. And that way the garage door doesn't read the sensor in the middle of opening or closing the garage door and think, oh, I need to trigger it again because it's not the correct state. And then we have a whole bunch of variables here. Some of them, like the reply topic I described in the last video, and we will actually be using that in this video now. And that will basically represent the status of the garage door, which I'll also get to in a moment. Down here, we have our relay and sensor pins, and I think I actually reconfigured the pins a little bit from the previous video. So now the relay pin is on 2 and the sensor pin is on 3. So I have 2 sets of variables here, current state and target state, and current mode and last posted mode. And these are basically internal ways for the ESP to keep track of both what the door is actually open or closed and the current mode. Now the modes, I'm actually going to have 4 different modes, and they will be 0 for open, 1 for closed, 2 for opening, and 3 for closing. And I will explain later on in this video why I'm using those specific numbers and where they're going to be used in the future. But for right now, I'm just going to leave that a little bit of a secret because it's also going to be shown in an upcoming video. Then we also have this running variable, and this just keeps track of whether or not the door is actively opening or closing, and a toggle start time variable that keeps track of when I started my open or closed toggled session. So this time plus 19 seconds will be how I keep track of how long it's taking for the door to open or close. And then here we have a whole bunch of information for ESP helper that, if you've seen any of my other videos, should be pretty familiar. I do have 3 new fields here as part of net info, which is a MQTT username and password and port, which are 3 things that you guys have asked for a long time. So I finally got it updated, and you can use MQTT usernames and passwords and define a custom port. So that takes care of all the variables. I know there are a lot of them, but hopefully it will make sense in just a couple minutes how they're all being used. So in setup, we define our output for our relay pin and input for our sensor pin. And we generate our status topic string and set up ESP helper. If this all looks foreign to you, go and check out one of my ESP helper tutorial videos. It explains how all of this works. And then we come down here into loop. It's kind of long, but you'll see how it works, and it's pretty simple. The first thing we do is we set our previous state equal to current state. So the 2 of them are equal to each other. That way, if current state changes, we have a way to check whether or not it changed and how it changed. So the first thing we do is we read our sensor pin, and if it's not equal to the previous state, we wait a little bit of time and then read it again. And if both of the times that we read it, it's not equal to previous state, we're then going to set current state equal to not previous state, which also should be the same as not current state, because at the moment before this line they were equal to each other. So basically, if current state was true, now it's equal to false, and vice versa. Which brings us down to the next if statement here, which asks whether or not the current state is equal or not to target state. Basically, if they're not equal to each other, what that means is that the door should either be opened or closed. Basically, if the current state is closed and we want it to be open, we then need to toggle the door and tell it to open the door. So what we do is we check to see if current state is low, i.e. it's open and needs to be closed, because up here our target state is not equal to current state. So if we want to close it, we're going to set our mode to 3, which is closing, and then we'll skip this. This, by the way, does the exact opposite. If the door is closed, we set it to 2, and it will see that as needing to open, so opening. And then we look and see if the last posted mode is not equal to current mode. So if they don't match, then we want to set the last posted mode equal to current mode and post the newly changed mode. So maybe we were closed, so we were at a mode of 1, and we want to open it, which just changed the mode to 2. And so these two modes will not equal each other, and we will send a 2 to the reply topic. I know this seems a little bit confusing, but I think later on, when you guys actually see it running, it will make more sense. So the last thing we do here, if the current and target state are not equal to each other, we toggle the door. And toggle door just comes down here, and we have this little if statement that checks for the timing, whether or not it's actually opening or closing currently. And as long as it's not opening or closing currently, as long as it's not actually trying to do something right now, we will check to see if it's running. If it's not running, we will start it running. We will trigger the door to open or close, set our start time, and set running equal to true. And that will just make it so now the door is actually moving. So that is all the code that has to do with actually toggling the door open or closed. But there's a little bit more here in loop, and that is this section here. And assuming that the door is not needing to be opened or closed, this is what's going to happen. We will check to see if the current state is low. If it is, i.e. the door is open, we will set the mode to 0. And otherwise, we will set the mode to 1 because that means that the door is closed. So just like we did up here, this same little if statement up here, we're doing something very similar here. We're checking our modes, and if they don't match, because maybe the door was just closing and now it is closed, so we want to post a 1, we'll check if they're not equal to each other. As long as they aren't equal to each other, we will now set them equal to each other so we don't keep triggering this. And we will post a 1 or a 0 depending on what state the door is actually in. So it seems kind of complicated, but basically what it boils down to is check the sensor, decide whether the door needs to open or close. If it needs to open or close, send a signal to say that it's opening or closing and toggle the door. And if it's not opening or closing, then we want to check the state. And if the state has changed, we want to post either a 1 or a 0 saying that it is open or closed. It's a lot of code, but it's pretty simple when you actually kind of break it down. I promise we are almost done here and we can get to the demo in just a moment. But there's one more little section here, and that is our callback. So our callback last time, we just sent a 1 to the MQTT topic, and that 1 would just toggle the door open or closed. We're going to change that a little bit now because we actually can register which state we are in. And what we're going to do is if we get a 0, we will set the target state to false, which is the same as open. And if we get a 1, we will set it to true, which is close. So this way we can actually say specifically, I want the door to be open or closed. I do, however, have one last thing in here, which is if we receive a 2, we'll basically just do what we did before. We'll just toggle the target state. So if it was open, we'll set it to closed and vice versa. All right, now that we've taken a look at the code, let's go and actually see it working in a live demo. All right, so here we are back in my garage, and I once again apologize for the acoustics in here. And if we look at the top, you can see I have installed my little rangefinder and it's blinking away, telling me that it's taking readings. And that is wired all the way back to my little ESP module here, which is blinking away, connected to the network. So if you guys take a look in the bottom right hand of the screen, I have a little terminal window popped up, and it's subscribed to the status topic of the ESP. So when I push the button, it will send a signal to the ESP to open the door, and the door will start to open, and the ESP will send to the status topic, it will send a number 2 indicating that it's opening the door. Once the door is opened, it'll send the number 0 to say that it's open. And then when I push the button again, it will send a number 3 to indicate that it's closing the door, and a 1 to indicate that the door is closed. So let's check this all out. I will speed it up so you guys don't have to sit here and listen to all of this garage. Alright, so there you have it. The garage door has detected all 4 states: open, opening, closed, and closing. And all of this is actually leading into the final video that we're going to make for the garage door, which will be just an explanation of the iOS HomeKit app that I have put together here. And that will be the last video. So if you guys like watching this and you want to see that video, definitely give this one a thumbs up and subscribe to the channel. And don't forget to go to patreon.com/ItKindaWorks and toss in just a couple dollars here or there, whatever you can spare, and it just all goes to help making the channel better. Alright guys, thanks for watching. I'll see you guys next time.